We are starting at page 98. The activity getting started title is the escalator or the stairs. So we're starting at 98. We're going to complete this getting started and first activity and then the second activity, and I'll tell you what your assignment is after this. But this says, so go to page 98. In the box it says Bob rides an escalator. The escalator starts at point 0, so we're going to make some annotations. I'd like for you to copy this down. At 0, 0. And drops Bob off at the coordinate 12, 8. So that's 12 to the right and 8 up. So right here. Alice starts at the same point, but takes the stairs. So she's going from point A to point B, from that bottom left at the origin to that point at 12, 8. Okay. Here, pretty simple. Number 1, draw a line to show Bob's path on the escalator. So we'll just draw right here. Okay, so this is represented by Bob here. So we're done with that. Step 2, draw steps starting at the origin that will take Alice to the same location as Bob. Make all the steps the same, right? As you go upstairs, right, you don't really see like steps that are of different sizes. They're all pretty much equal shape, equal size. So I guess looking at this, right, how many steps? And what are the size of each one of those steps? So answers will vary, but I'll give you just kind of a generic example here. We're going to say that the steps that we're going to take starting here, I'm going to put this in red. I'm going to go up 2 and let's say 3 to the right. So go ahead and draw that. So that's the first step. And we're just going to copy and paste this, still going up 2 and 3 right. So up 2, we're now at a height of 4, 3 right. We're now at a width of 6 on the x-axis. So let's keep going. Up 2, right 3, up 2, right 3. So what's in red here is Alice's path, whereas the black line is Bob's path. Okay, so we drew that there, so we don't have to answer anything in this space. But for number 3, we will. How is taking the stairs similar to riding the escalator? How's it different? Okay, so we're gonna say for this, starts. Well, we'll say starts and ends. Oops. At the same place. Okay. We'll say that the escalator is smooth. We're just kind of going along a path. While the steps, we're going to have to kind of write on here. Steps go up and down. Oh, just realized I put this in the wrong place. Whoops. All right, we can fix that. Sorry about that. If you put it in the second spot, I apologize. Just put an arrow to number 3. And then number 4, compare the steps that you designed for Alice with your classmates. This we're not really going to do, but how are these steps similar to your steps? Instead of that, what we're going to put is what are some other things that we could have done to get from the origin to the coordinate 12, 8. So we went 2 up and 3 right. Now, what else could we have done? We could have also done, let's say, pretty much anything that can divide the coordinate 12, 8. So you could have also went, let's say, up, oh no, not up 4, up 3, and right, so divided by 4. Yeah, so you could also, I believe you could also went 3. Could we have done 3? No, not that. Oh, because I have to switch. We could have also done, let me get rid of that. We could have also done, I believe, 4 and 6. Yeah, 4 up and 6 to the right. There's a couple of other options. You could have went like, decimal options, but these are for the most part just whole numbers here. Pretty much any ratio. So we'll say any ratio that equals a 12:8 ratio. Meaning, if I can simplify this, right, we can say, right, a 3:2 ratio right here. We can also say a 6:2 ratio. They're all equivalent, and we can simplify the first one to be any one of these. Okay. Anyway, so just give us a little bit of an introduction to paths that we've talked about last week. But let's go to the next page, 99, for activity 1. We're going to go through the worked example, but we actually have some experience with this. So it says scaling up and down on the coordinate plane. What we have here is, it says dilate triangle ABC by a scale factor of 3, and we're going about the origin as the center of dilation. And it's telling us, it's just saying, you know what, go ahead and graph. It's already worked out point A, which is at the coordinate 2, 1 right here. And it's having us do this in a slightly bit of a different way. Off to the right, it says point A is 2 right, 1 up. It says dilate point A by a scale factor of 3. And essentially, the steps that we had on the previous page, we're just kind of replicating those steps. So one example here. So I want you to trace this. So right there. That is one step. And what they're saying here is we're going to copy that. Whoops. And we're going to just say for this, we'll take 3 of these paths. Okay, so let's copy, paste, and I'll paste again. So here I can move this path right there, and then move this path right here. Whoops. Just like that. Okay. So now we've done it in a different way, right, by multiplying our paths, but this is saying you can take that many paths there. All right, so we're going to do this for the other ones as well. So number 1, describe the repeated translation you can use to scale point B, and C, we'll start with point A to figure out where is, B for B prime. A is already given to us, it's on the graph. So the path from the origin to B looks like it is 4 right and 2 up. So 4 right and 2 up. So we're going to take that path and we're going to copy and paste it. I like for you just to go 4 right and 2 up. So it's gonna be right over here like that. So point B prime, I'm gonna get rid of this. It should be 1, 2, 3, 4, 2 up. Should be right over here. Oh, whoops, I made a mistake there. We should have this path one more time because our scale factor is 3. So 4 right, 2 up, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2. So it looks like it's going to be right over here at the coordinate. Should be 9, 9. Oh. So the path from the origin to B, sorry about that, that is 3, 3. I was looking at the wrong point. So 3, 3, we're going to multiply that by 3. That's where we get 9, 9. So this is the point B prime. Sorry about that. So we're going to say 3 repeated translations of going right 3 and up 3. Puts B prime at 9, 9. Okay. All right, and the final point here, we're going to now figure out C prime. So C prime is right here. This is the one that's 4 right and 2 up. Sorry about that. Oh, no. I'm looking at the wrong thing. This is 4 right, 1 up. I'm looking at the other object. So right here. So 4 right, 1 up. So we're going to continue going 4 right, 1 up. So 1, 2, 3, 4, 1 up. 1, 2, 3, 4, 1 up. So right here is where C prime is at. Okay. So we're going to connect all three, like that. So for this we were just going to say 3 repeated translations of going right 4 and 1 up. Puts C prime at, and that is the coordinate 12, 3. Okay, right. So let's answer some questions here. We already did number 2. Right, we drew the figure. Now the question is triangle ABC similar to triangle A prime, B prime, C prime? We're just answering, is this shape right here, is it the same shape, right, as this one? Meaning if I were to either make triangle ABC bigger, would it match this image triangle, or the image triangle, if I were to shrink that, would it match the smaller one? This is, yes, they are similar. Yes. The 2 triangles are similar. We'll just say same shape, and it doesn't matter for size for that. As long as they're the same shape, they are similar, meaning that their interior angles are equal. Their side lengths might be different, but that's for size. Okay. All right, and then now let's move on to the second part of activity 2, working a little bit of a different way, which is now instead of enlargement, we have a reduction here. So this is saying we're going to take triangle DEF, and we're going to reduce it by a scale factor of 1/4. Now we remember 1/4 means to divide by 4. So they started at the point 4, 4 here, which is D. And they said instead of going 4 right and 4 up, they went 1 right and 1 up, meaning they reduced it. They divided it. They had to do some calculation. They got the point of going 1 right, 1 up, which is right here for D prime. Okay, we're going to do the same thing for the other ones. Determine the points for E prime and F prime. Let's start with, we'll go alphabetical order. We'll go E right here. So E is, looks like we are going 8 right, 8 up. I'll put E is, we'll say +8 for the first one, and then +8 for the Y. If we divide this by 4, that means E prime is going to be, so what's 8 divided by 4? Right, it's 2. So this will be 2 to the right and 2 up. So 2 to the right and 2 up, just graphing this on here, it is right over here. This is our new point, E prime, whereas this is D prime. One more, let's figure out F. F is, looks like it is 12 right, 4 up. So we'll put +12, +4 for the y-axis. And then that means F prime will be, divide both those by 4. 12 divided by 4 is 3. And 4 divided by 4 is 1. So 3 to the right, 1 up. So 3 right, 1 up. That's right here. That is F prime. And now let's connect all 3 dots to form our triangle that has been reduced by a factor of 4. I'll color this in just because there's a lot of stuff happening, and so you know which triangle we're talking about. Okay. All right. Number 4. How do you know that triangle DEF is similar to the other triangle? We're going to say that each point is dilated by a scale factor of 1/4. Right, so if you take each one of them, since they all have the same scale factor, we worked on this in Map Accelerator. If they all have the same scale factor, that means they are similar. There is a common thing that's either being multiplied or divided. And how does dilating a figure using the origin as a center of dilation affect the coordinates of the original figure? Pretty much what just happened here is you either multiply / divide, we'll abbreviate, each value in a coordinate by a common factor. So that's all we got to do. We looked at past, but since it is from the origin, it makes our life a little bit easier. You just either multiply or divide the ordered pair, the values in the ordered pair. Okay, we're gonna move on to activity 2 to put that information now into practice. So we are now on moving from page 100 to now 101. Using the origin as the center. Okay, so we have here we're focusing on this road sign. It says road signs contain a constant scale regardless of whether they are on the road or on the driver's manual. So for those that aren't familiar, right, adults, they have they have cars, they have owner's manual, and they're predominantly in their glove box. And you'll see this same exact figure here, right, just to let you know varying signs on the road. But this, right, when you see it on the road, it's a different size. It's obviously bigger so drivers can see. And then this one just says that the road bends to the left. That's what this thing means. Number 1, dilate the figure on the coordinate plane using the origin as a center of dilation. And we're going to now use, kind of using a common factor here of scale factor of 3, and then complete the table. So we already have these coordinates written over here. What we're going to do here is put that information that we used to practice. Since our scale factor is 3, that means I'm going to multiply everything by 3 here. So let's go ahead and put what A prime, B prime, and C prime, and D prime are. If we multiply each one by 3, A prime is 6, 9. Right, if you multiply 2 times 3 is 6, 3 times 3 is 9. Let's graph that. 6, 9 is right here. We'll label this A prime. B is 4, 3, so B prime, multiply it by 3. This is 12, 9. So 12 to the right gets us all the way to the edge of the graph. 9 up is right here. So B prime. C prime, this is 12, 3, right? 1 times 3 is 3. So that's 12 to the right and 3 up. So we're right over here. This is C prime. And then for our last one, 2, 1, D prime multiplied by 3 is 6, 3. 6 to the right and 3 up. So it looks like it's right over here. We'll label that D prime. We'll connect each one of our points. Now we only have the points for the outside of this figure, but we can still draw this entire thing. What I mean by this is that we have this somewhat like arrow inside. We're just gonna do this. We'll just kind of freehand draw it. Let's see, it looks like this. I think this goes from the center to the edge. And you don't have to color it in, but I don't know. Let's make it kind of look the same of what we originally had. All right, so number 2. How does the dilation affect the values of the coordinates? So we're going to say that the x and y coordinates, I'll just put COORD for coordinates, are all multiplied. I'll put MULT for multiplied by the scale factor. Okay. Number 3. Describe the relationship between the corresponding angles and side lengths. So the angles here of everything, the angles are the same. So we're going to say angles are, and when we talk about a shape, we can say that they're equal, but specifically for shapes, you say that they are congruent. Same shape, same size. So angles are congruent. The only thing is the side lengths, right? Are the side lengths the same? Meaning, right, from A to D, is that the same size as A prime to D prime? No, it's obviously bigger. So we're going to say side lengths form, right, it was, we got it bigger. So this is, right, for each, we'll say this was 2 units. Now this is 6 units. This is a 1-to-3 ratio, meaning everything that's 1 unit tall is now 3 units tall. Okay. All right, and then now let's move on to the last and final page, part 2 of our activity on activity 2. So continue. Now we got a different road sign. This one says road proceeds to the right, and we got this arrow pointing to the right. We've got a bigger figure, now we're going to reduce it. So this is a reduction. We're going to reduce it by a scale factor of 1/2. So it's gonna be half as big. So right, we can look at the figure itself, but we're gonna use the coordinates here. We're gonna say everything is technically multiplied by a half, but we know this to mean as divide by 2. Multiplying by a half is the same thing as dividing by 2. So let's figure out what is all the image points. So W prime, divide 8, 10 by 2. This is 4, 5. 4 to the right, 5 up. This is going to be really small. X prime, 10, 8 becomes 5, 4. 5 right, 4 up. Oh, sorry, I didn't label these. This is W prime. And this is X prime. Y prime, 8, 6 becomes 4, 3. Divide both those by 2 again. 4, 3, 4 right, 3 up. Right here, we'll put Y prime. And the last one, Z prime. 6, 8 becomes 3, 4. 3, 4, 3 right, 4 up. And this we'll label. And as you can see here, we've got these 4 points here. They kind of look like this, but it's reduced by a factor of 2. I'm just going to draw kind of a linear arrow like that. I'm not going to make it like a bubble arrow. Anyways, so that's what we get here. This is something that's been reduced by 2. We'll talk about the ratio here, but let's get to number 5. How does the dilation affect the values of the coordinates? We're just going to say that they're all halved. So the past tense of halve. Right, the x and y values are halved. And number 6, describe the relationship between the corresponding angles and side lengths. So angles, what do I mean by this? Is this angle right here, is this angle right here bigger, smaller, or are they the same? They're exactly the same. So these two angles are equivalent. These two angles are equivalent as well. And you can say the same for all of them. So we're just going to say, right, same for the last one. Angles are, they're equivalent, but we're going to say congruent since we're talking about shapes. All right, and the side lengths. Side lengths are, let's look at them. Okay, so we have something, let's say z to y, and now z prime to y prime. Now, it's kind of hard to measure lengths when you're looking at it diagonally, but I'm going to compare this. This part you don't have to write. I'll put this in red. We go 2 down and 2 right to get from one point to another point that's on this figure. For the same thing of the image, we go 1 down and 1 right. So 2, 2, this is 1, 1. So what originally started as 2 down and 2 right is now 1 down and 1 right. That cues you in on what the scale factor is. It got smaller, 2 to 1. And what did I divide 2 by to get 1? It was 2. So this is, side lengths are, we're going to say a 2 to 1 ratio. Right, means just it got divided by 2. I'll put div by 2. All right. So we're going to end it there. After this, you're going to open up you're going to keep your devices open for Map Accelerator. You're working on, I believe it's dilating shapes. It's a new one for today and due tomorrow. If you finish that a little bit early, you'll be working on Map